All right, so final exam questions. There's 18 of them. The best representation of what you're going to see on the final exam. So let's go through it. Blah blah blah. Anyway, I know in our matrix units we did a lot of different applications. We did like mark-out change, Levy model, that kind of stuff. But I predict if you're going to be given matrices problems, it's probably just going to be like basic matrices. Okay, I guarantee it's probably going to be something like where like the rows and the columns mean something, and they just ask you to do like a basic multiplication type operation, just to see if you understand what matrices are. Okay, so here it's talking about like these are all the different crews that we have, and this is like the number of crews required for each house, apartment, and offices. So it wants to see if you can understand how it's read. So like you need 11 building crews per one house. Okay, just what the problem's saying. And if you read the choice here, it says the company is currently working on 9 houses. Okay, we got 9 houses, 2 apartment buildings, and 6 office buildings. Which statement is true? Well, more building crews working on offices than on houses. Electrical crews working on apartments than on offices. Plumbing crews, landscaping crews. It's saying, it's giving you comparison between each of the 4 crews, between houses, apartments, and offices. All you have to do is just go through and see which one's bigger. Too bad. But you just got to understand how to do it. So what do I do? How do I figure that out? These numbers given. Multiply, right? And you don't, it's not even, you don't have to set up another matrix multiplication if you don't want to. Just think about what to multiply. If I say 9 houses, okay, well here's my houses column, and these are for just a single house. Well, you just multiply all that by 9, 9, 9, 9, 9. Anyway, and that'll tell me how many crews I need for each one. Same thing for apartments. I'm working on 2. So 2, 2, 2, 2. And same thing for offices. I'm doing 6 offices, so I need 6 for each. Yeah. Anyway, let's go through them. So we're looking at building crews first. It says you got more of them working on offices than on houses. Is that true? Sure. 23 times 6, I believe, is greater than 11 times 9. Right? 11 times 9 is 99. And then 23 times 6 is bigger than 100. There you go. Yay. And I mean, you can test the other ones, but that is the right answer. Questions on that? I mean, it's going to be something like that. Okay, we just have to multiply. Now, surprise! This is one of the higher percentages of the questions they got right. 72% of people got this one right. Dude, you are going to ask yourself that a lot as we go through some of these problems. That is probably the second highest percentage on here. We're all very low. Most of them at 50 or below. You got to think about this, guys. Like, I know y'all probably don't really consider it because of where you're raised and stuff, but y'all are like everybody in the state industry is taking the same thing. Compared to everybody in the state, around the country, y'all are pretty good. Y'all are well off. Y'all are bright. Y'all are. No. Well, come on. No, it's not. I mean, come on. It's just like how you were brought up, how you're raised. That's like kids. So usually y'all are above the percentages. Okay. Anyway, not to make you feel that way. No, that's not what I'm saying. Yeah, please study. Okay, let's go on to number 2. This should look familiar. It is though. The graph. This is a graph right below. Displays a relationship between 7 locations. That's graph theory. Remember how graph theory, all that does is it shows how dots are the relationships between vertices, like the lines represent relationships. Mm-hmm. And all it wants us to do in this problem is says, can an Euler path be drawn for this graph? How do I determine if we have an Euler graph?
You have to get every point.
Exactly 2 odd vertices. Absolutely, yeah. It's all about the degree of the vertices. So an Euler path is exactly 2 odds. What about an Euler circuit? No odds, or just all evens?
Yes.
Yes. And remember, a path is like you start and end at two different spots and do what? Hit every single point, but also every single edge once and only once. That's what a Euler path in circle does. Hamilton is every single vertex. All right, but just so we got to go through and really just count the degrees of this graph. So like right here, it's 2, 1, 2, 3, 4, 2, 1, 2, 3, 4, 5, 6. So right now we're all even. 1, 2, there's 3. Okay, there's one of my odds. 4, 5. So do we have an Euler path? Yes, absolutely. Okay, because we have exactly two odds. So what does that mean my answer choice is? C. Yes, because there are exactly two odds. We're 50% of people that got this one correct. 33 close. 51%. Half the people, yeah. I mean, it's just the other half just didn't know what a path was. Yeah. Might be able to pull that information up. I don't have it with me right now. I might be able to pull the bar graph. See what I'm looking at. You're gonna see some of these percentages. Like it gets down to the teens. Like you have, like if you guess, your probability is higher than that. Like that's what bothers me. I don't even know how you get below 6% counts. Alright, look at this. Again, hey, this is another graph theory problem. Does this look familiar when we have a start and we're going to a finish? It's a scheduling problem. It says which of the what is the critical path for the diagram below? What does critical path mean? Remember? Longest. Yes. People always mix that up. I think that's why this has a low probability of getting it right, because it's the longest path. The longest path ensures that I hit every single precedence relationship and I get my task done. If you go down any path shorter than that, you're not going to complete your task. So technically, the critical path or the longest path is the shortest amount of time it takes to complete the whole thing. In this particular example, though, we only got, let's see, 1 here, we have 2 here, or 3 paths to the end. We only have 3 paths that we have to check to see which one's long. It's not that hard. It's not that big a deal. All you do is add it up. That's it. But remember the examples we looked at, the paths were usually kind of crazy. We had a lot of paths from start to end. Do you remember how we determined the critical path, like the easiest way? Backwards. Absolutely. So like start with J. We
That's probably true. And it's one of the last days.
It's the second to last day to get you to answer a question. But hey, you answered. I appreciate that, man. That's awesome. Yeah. Look at around. There you go. So let's keep going backwards, man. Oh man. Alright, so that's 1. And if it's just pointing to one thing, you just add it, right? So like 3 and 1 is 4. 8 and 1 is 9. Just keep going. Let's see, 2 and 1 is 3. See, like I said, this is a very simple graph. It probably wasn't necessary, but at least we're practicing. 6 and 4 is 10. 9 and 3 is 12. All right, what about D? Which one do I add? Which direction do I go in? Yeah, the 6 and 12 is 18. 5 and 10 is 15. Again, we're in a point where vertex is pointing to two things. What do I add the B to? Yeah, 7 and 18. I don't know why its processing time is different in either direction, but it is. 25. And then, I mean, you can keep going, 28. But it looks like our minimum time here, our project minimum time is 28. What's the path that gave me that? Yeah, I think it's C. A, B, D, F, I, J, 1. Just for a second. Was that C? Is that kind of coming back to you? There's another question like this, like the next question, so I'm assuming they'll probably ask me like one of these questions for graph theory. What's the percent?
25.
35%. You said 45, right? Oh, dang, I didn't say 35. I said 45. Yeah, 35% got that. That's fixed. Yeah, sure. Whatever. Big there is.
There's a curve on everything.
There's always a curve on state exams. The teacher says there's not a line. All right, how about this one? A student needs to complete the task list below for a project. I'm giving you tasks. I'm giving you the time it takes to complete it. And I'm giving you a prerequisite. I'm asking for the minimum amount of time it will take the student to complete the task list. Project minimum time. What do you think I'm going to have to draw? What do you think I'm going to have to do here? Draw something, right? I'm going to have to draw a graph. Draw that project diagram. It's going to look just like the one in the previous problem, basically. Okay, so this requires one extra step. You got to draw it first. Which I did on the whiteboard, but I guess for the video I should come do it here. Hold on. Okay, let's draw it. Now remember, with these project diagrams or whatever, you always start with start, and you work your way left to right, and you're pointing in the right direction. Okay. What does start point to? Yeah, it points to the ones that don't have any precedence, right? In this case, it's 1 and 2. So, okay, let's stick with that. I hate that there's numbers for the task and for the processing time, but, well. Yeah, let's make it ABC. That's A, B, C, D, E, F, G, H. I'm just changing it to letters because somebody last class. Okay, whatever. I'm changing it to letters because, I don't know, I don't like seeing those for tasks. So I have to do the same thing over here. So that'll be like A, B, dang it, that's AC. Well, don't mess up like Forbes. A, C, B, D, D, E, F, G.
Yeah, G.
Hey, that's not terrible.
Yeah.
That's better. What do I start with what? The tiny line. I don't know. I've never made a real G before, okay? My G's are 6s apparently. I don't know.
Yeah.
Anyway, let's go through it. All right, so I'm gonna have to go back and forth here. See what? Do what? My G's? My G's are great. Okay.
Yeah, no.
Anyway. People watching this video are like, oh my god, just go on with it already. So, hopefully they're probably skipping.
They're not watching.
Or they are not.
They're not even doing.
That is very true. God, alright. Alright, whatever. If you're watching this video, come to my classroom to receive the prize.
Oh, no.
That's nothing. Alright, no, I'll give you something. I'll give you a high five. Okay, so in this case, from the start, we are coming. There's two things that don't have prereqs, right? I believe those tasks are A and B. Okay, so we got A and B. A with a processing time of I think it's 5, and B with a processing time of 10. Okay, y'all gonna have to help me out here because I do not want to go back and forth between here. Let's see. Yeah, so, shh, don't tell me the answer. Anyway, we're just going to keep going. My suggestion is if you're given a task list, like, work your way down the list. Okay, so we've done A and B, they're both ready. Like, look at C next. Is C ready to go? Yeah, absolutely. It needs A. So it's going to be branching off from A. If you look at the task list, it's prerequisite. I'm going to put C with a prereq of, or I'm sorry, processing time of 10. We'll move on to D. Is D ready to go? Yeah, it needs its prereqs of C and B, both of which have been completed. And remember, it has a prereq, or a, God, I can't say it, processing time of 8. That's what I get for looking at my freaking paper. So it doesn't come off a B?
No.
I apologize for that, everybody. Anybody watching? Once again, no one. I got it. Ha ha, dang it. Do these videos and nobody watch it. But yeah, its prereqs are A and C. So like the A is already pointing to C. So do I need to have another arrow going from A to D? No, it's not necessary. Okay. All right. So we've gone through D. Let's look at E. Is E's prerequisites done? Which are B and D. Good. So I'm going to go B and D to E with its processing time of 4. All right, going on to F. Is F ready? Yeah, what's it need? D. So I'm going to go from D to F with its processing time of 10. Okay, so we're through F. Let's go down to D, F, G. What's G's process? Everything. Is it ready to go?
E and F.
It's coming off of E and F, right? So E, F, we're at G with its processing time of 18. And I'm almost done, so I'm looking up there. And the last one's H. What's H prereq? G. So I go from G to H with its processing time of 7. And then I'm at the end. Yay! You think you can make that? Think you did on your own? Not too bad. Now the only thing it wants you to do is just figure out which of those is the shortest or longest. Longest. Okay, I know it's asking for the minimum amount of time, but remember you find that by looking at your critical path, the longest path. Again, let's see. That's only like 1, 2, or 3 different paths to check. You only have to check 3. So your backflow algorithm might not be the best thing, but we're going to do it anyway. Let's do the forward one. I guess since the last example we did the backwards one, how about with this one we do the forward one? Why not? Okay, working forwards, like what's the weight of that? That's too much to me.
33.
Oh my god. So that's 28 plus 5 is 33 plus 7 is 40.
58.
See, that's why I don't like doing this. I'm doing backflow algorithm.
15.
I'm doing backflow algorithm. I forgot the 18 too.
I got 58.
Backflow algorithm. So we're doing 7. Working backwards, 18 and 7 is... All right, 10 is only pointing to one thing, so 10 and 25 is 35. 4 is only pointing to one thing, so 4 and 25 is 29. All right, but let's see. So D is pointing to 2 things. It's pointing to the F and to the E. So which one does it go with? F. 8 and 35 is 43. All right, let's keep going. So C is only pointing to one thing. 10 and 43 is 53. This is only pointing to one thing. So B, or 10 plus 29 is 39. And A is only pointing to one thing. So 5 and 53 is 58. So which one is my which one is my critical path? What's my number here? 58. Which is C. My goodness, what is the percent there?
30.
31. 31.
All right.
So it's all
Another question.
Oh man, C. All right, questions on that? These next 3 go by pretty quick, so that's good. This one I think requires the most work on the problems. But these next 2 should be pretty familiar. It says 5, which group and purpose would work best in a census survey? So we just talked about what a survey was. A survey is just like answering questions, right? Answering questions to learn information. What we didn't really talk about is the specific type of survey. If I'm talking about a census survey, that's a survey that that's how do I say this? That asks everybody in the population you're studying. Think about what a census is. A census like pretty much gathers information about the population. That's kind of what a census is. A census survey is asking everybody in the population that you're studying. Okay, that's what that means. So population and not sample. So basically, we just got to figure out which situation corresponds to that. Let's read them. Students in one class determine what students in the school think about school lunches. The workers in an entire office building to determine the most preferred day for weekly meetings. The citizens of one county to determine who is preferred nationally in an upcoming presidential election. And the citizens of an entire city to determine what citizens think about tourism in their entire state. What do you think? B? Why B? The population. Think about what the population is. We're asking everybody in the office building, okay? And the population that we're trying to determine is everybody in the office building, because we're talking about the most preferred day for weekly meetings. The population is the entire office. Like here, we're doing one class to the whole school. We're doing one county to the nation, and we're doing a city to the entire state. So none of those work. Any questions on 5? Number 6, we just tested on, so please God, I hope we get this one right. Oh, what's the percentage for number 5?
7.
How's that? 46. Yeah, still less than 50 though. I mean, God. Alright, number 6. The amount of time Mr. Smith spends exercising each day is approximately normally distributed. Key word there, normally distributed. I'm giving you a mean of 30 minutes. I'm giving you a standard deviation of 10 minutes. These are all key words here, people. Approximately what percent of days in a year does Mr. Smith exercise between 10 and 40 minutes? Calculator. What are we doing in our calculator?
Normal CDF.
Yeah. Normal CDF, thank God. Absolutely. Okay, if it's giving you your mean, standard deviation, it's asking for probability. All right, that is always normal CDF. Okay, so remember in that screen, you're going to have to type in a lower, an upper, your mean, and your standard deviation. Just a refresher, it's second bars. Option number 2. What's my lower? 10. What's my upper?
40.
What is my mean?
30.
What is my standard deviation? Oh, and by the way, I'm trying to have your stats test created by tomorrow so we can talk about it, because it is a big portion of your final exam. It should be good to go over. So. Anyway, when you do that in the calculator, anybody do it already?
Yeah.
No, I know some of y'all don't have it.
82.
82. You could do the empirical. You're the only one that's ever said that. Yeah. 10 and 40 are exact standard deviations away from the mean. 10 is 2 standard deviations below the mean, and 40 is 1 standard deviation above the mean. So you could do the percentages from the empirical rule. It would have given you the same answer. I just like using the calculator. Any questions on 6? All right. Let's go on to number 7. Again, another stats problem. Oh, wait, the percentage of that, by the way? 45%. Stem and leaf plot shown below. We know how to read a stem and leaf plot. We've seen this before. It says, which best describes the distribution of the data? Look at your answer choices. Skewed right, skewed left, symmetric, bimodal. We talked about bimodal before? No. Nah, let's scratch it out. It's not the answer, right? They were describing a data, it's asking for the shape, right? These are the 3 ways we talked about how to describe it. Symmetric left, right, and skewed right, left, and symmetric. What do you think? Which way is this skewed? Right, left, symmetric? Yeah, I'd say right. Look, if you kind of drew it out a little bit, okay, yeah, whatever. You can kind of see the details over here to the right. The idea is that a majority of your data is right here at 2 or 3, okay? And wherever you have extreme values in the end, the direction you have it in, that's where your skewness is at. So since we have really big values, that's going to be skewed right. Okay? Did you get that right on the test? And what's the percent? More than that.
60.
Absolutely. Because they probably used to seeing it like up and down instead of like side like that. It's 41%. This next one is these next we got two more. Those are pretty low percents. But this question right here, there's like 3 of these on here, I feel like. Okay? This is number 8. This question just pops up. This is why I kind of chose the probability unit to be one of our last units. Let's see if we can remember it. A spinner is divided into 12 sections that are equally likely to occur. Okay, 12-section spinner. A to L. Philip will spin the spinner 3 times. Okay, cool. What is the probability that the spinner will land on the letter G exactly? Exactly 1 out of 3 times. I think that word is kind of important.
I don't know.
You go to the second parse, which is the option we pick. Oh,
It's PDF.
it's PDF, binomial PDF. Exactly with probability. If I'm telling you I'm doing something, if I'm telling you that we're doing something a number of times, and I'm asking for an exact probability here, like exactly 1 out of 3, that is binomial PDF. Okay? Yes, binomial PDF. So it's the same menu as normal CDF and PDF. You're going to go to second varse. That's option A. So second varse, number A. I think it's something. And when you get that screen, it's going to ask for 3 things. It's going to ask for your trials. It's going to ask for your probability of success, and it's going to ask for your X value. Okay. Now, what's the number of trials in this case? 3. We're spinning it 3 times. It's the number of times I'm doing something. Okay, 3. Now, the probability of success is always going to represent the probability of what I'm getting once. So, like, what's the probability of getting the G once? 1 out of 12. That is 1 out of 12 chance. But the X value is the value that tells me how many times I want that success, which is what in this case? 4. Now, when I do this in the calculator, I end up getting like, I think, point 2 something, 0.22 something. But you can convert that to a fraction. Anybody do it already that has a calculator? Sweet. You get that? What do you think the percent is?
18.
29%. 29%. Yeah. That's pretty good. 29%. Yes, we'll see an example of that later on tomorrow. Number
11.
Yeah, number 11. Very good. And number 11 is the smallest probability of correctness, smallest percentage being correct.
18.
Yeah, 18%.
Really?
Yeah, that's the smallest percentage. 18% getting number 11 correct. You can literally guess and have a higher chance. Like, that's what I don't think that.
Wait, what was the formula again? Like, figure 11?
So, like, if it's at least, that means that you need to do 1 minus the probability of 1 less than the value that it gives you. And we'll talk about number 11 tomorrow. I can talk to you about it in a second. But let's just go on to our last problem and we'll call it a day. All right, number 9. A school is selecting new members for a council. Okay? You got 10 seniors that are competing for 6 spots. We have 8 juniors for 5 spots, 9 sophomores for 4 spots, and 7 freshmen for 2 spots. This is what y'all do here, right? I mean, y'all have people campaign for spots at the student council. Y'all do the videos or whatever y'all do, and then y'all get the spots, right? It says, how many unique groupings of new members can a school make to fill the spots? How many ways can I get groups of these students in each category? How do you think I'm going to process it? All right, let's think about this. We have 4 different groups here. I want to know ways that those can be kind of like all the ways that, like I can do one with the other, I guess. So that implies multiplication. 1, 2, 3, 4. Got to do one thing times another thing times another. And what I'm trying to figure out here is all the unique groupings. So like, does it matter what order that I take these people out in? No, I'm not ranking them. I'm not giving them like class president or anything. But so what do you think I'm gonna have to do? That permutation is where order matters. Combination is the unique groups that do not matter. So like if I want to know all the ways I can get 6 spots out of 10, that would be 10 choose 6. 10 choose 6. It's not just seniors, it's juniors as well. So like I want to know all the ways of the 8 juniors I can pick groups of 5. Of the 9 sophomores I can pick 4. And of the 7 freshmen I can pick 2. And multiply. Permutation would say arrange, order, but if you see grouping, groups, unique groups, that's all combination. And the fact that we have more than one types of groups means we're going to have to multiply it because all the ways that can so to do that, a calculator is just under math, and you go over to PRB. And I think it's option number like 2 or 3. I think it's 3 actually. It's CR, right? And they're going to multiply them all together. I end up getting, can I take a guess? C. Good guess.
Yeah, C
When in doubt, C is your percent. What's the percent? 25. 25%. Like literally everyone guessed on that one. So whatever. These percentages disappoint me, but we're going to be higher than that. All right. Tomorrow we'll finish the rest of the 9 problems, and we'll be good.